Okay, nerds, let's get started. All right, so we're going to do some calculations on light. Okay, so for our direction to read each question, underline what you know, circle what we're trying to find out, identify what each equation you will be using, show all your work and units in performing the following calculations. Put a box around your final answer. And double check that that your final answer has the appropriate number of significant figures and the correct units. Okay, so there's a lot of stuff going on here, and it's our first time doing this, so I'm going to kind of talk you guys through it. Okay, so first up, our first equation at the top here, we have C equals F times lambda. Okay, another way of saying that is our frequency times our wavelength equals the speed of light. Okay, we're going to rewrite this. We're going to make a triangle. Bink. So C equals frequency times wavelength. Frequency times wavelength equals the speed of light. Okay? Yeah, if we can see that. So, the reason I made a triangle, anytime we're looking for something, so if I'm looking for C, I'm going to cover it up, and then we know we do F times lambda. If I'm looking for frequency, it's the speed of light divided by my wavelength. If I'm looking for wavelength, it's C over V, or C divided by frequency. Okay? So the triangle is just a way of making sure you set up the equation correctly and make sure we're not missing anything. Okay? Over here we have E photons, so the energy of a photon is equal by H times F. Okay? Now H is our Planck's constant. Okay, we have that written down in our notebooks, but that is 6.626 times 10 to the negative 34 joules per second. Okay, same thing, we're going to draw a little triangle. HF. Okay, so no matter what you're looking for, E over H will get you your frequency. Okay, if we're looking for energy, cover up energy, it's Planck's constant times F. Okay, so now let's write that in here, just so we have it on two sheets as well. H is Planck's constant times frequency. And E is the amount of energy. Okay, last equation. We have Planck's constant times the speed of light divided by lambda will get us energy. Okay, so we're going to make a triangle again. This is two different things, so H times C, energy, lambda. Okay, so if I wanted to solve for lambda, it'd be Planck's constant times the speed of light divided by energy. Okay, so the triangle's there just to kind of help us set up our equation, make sure we have it set up correctly as far as algebra. Okay, so let's do a few other things. We're going to be measuring frequency in hertz. Okay, hertz is the same thing as 1 over 1 second. That equals a hertz. Okay, or 1 cycle per every 1 second. Okay, and let's go ahead, let's get started. So, violet light has a wavelength of 4.10 times 10 to the negative 12 meters. What is the frequency of this light? Okay, so first thing we want to do is underline what we know. We know wavelength. We want to circle what we are trying to find. What is our frequency? Okay, so now we're going to go back to our equations. We have wavelength, we're looking for frequency. Right here, I'm guessing we're going to use this equation here. The other thing we might want to know is the speed of light. Speed of light is 2.998 times 10 to the 8th meter. per second. Okay, so this is our first time. We're going to set this up a little bit differently than what you guys do in your algebra class. Okay, so first thing we're going to do is we know everything in here. We're looking for frequency. We have our wavelength, and we know the speed of light. Okay, so right now we're searching for frequency. Like I just practiced, I'm going to cover up F. My equation should be C over lambda equals F. So that's the first thing I want to do. I'm going to write that down. Frequency equals C divided by lambda, or wavelength. And now we're going to set that up. Okay, so first one we want to do is we're going to start with our first number, which is the speed of light. Okay, draw it just like I do here. 2.998 times 10 to the 8th meter per every 1 second. Okay, this line stands for division. We're going this many meters per every 1 second. Okay, next thing is we want to divide it by lambda. Okay, so we're going to draw a new box for our new symbol. Okay, anything on the top is multiplied, anything on the bottom is divided. So our next one that we have is our wavelength is 4.10 times 10 to the negative 12th meter. Okay, we want that on the bottom. Okay, so up top we're just going to place 1 as a placeholder. Down here we're placing 4.10 times 10 to the negative 12th meter. Okay, so looking at this problem, we're taking C, we're dividing it by lambda. 1 and 1 don't do anything. Anything over 1 is fine, same thing. What we do want to have is we have meters on the top and we have meters on the bottom, so that cancels out. Use a different color. Meters is canceling out. Okay, and left. Let's see what we get. Make sure you guys can see this. Okay, so 2.998 times 10 to the 8th. We should probably talk about what that means. That means our decimal place is actually 8 places over. For placing an exponent into your calculator, we're going to put exponent, which is this key down here, which is times 10, okay, and now we just say to the 8th power. So this is 2.998 exponent 8. Okay, that's how we write this number here. We're going to divide by 1, we don't have to. We're going to multiply by 1, we don't have to. We're then going to divide, okay, by this number here. 4.10 exponent times 10 to the negative 12th. Negative 12. And what do you get? Okay, so we then get 7.312195 times 10 to the negative 9th. Okay, and I'm going to type it in one more time just to double check. Okay, 2.998 exponent 8 divided by 4.10 exponent negative 12. Okay, same answer. So now we get 7.31. So right now we're going to keep 3 sig figs. Okay, times 10 to the negative, or to the 19th. Okay, so in doing so, let's see, our meters cancels out, and this is per every 1 second. Okay, so we're looking for what is our frequency. Frequency we measure in hertz. Okay, so this number here, we have a number per every 1 second. This didn't cancel out. We have 1 per second. That is in hertz. Hz. So our units actually make sense. Put a box around it. Okay, let's do another one. Okay, particular light has a frequency of 6.01 times 10 to the 14th hertz. What is our wavelength in nanometers? Okay? This is a good time to bring up, let's say that every 1 meter is the same thing as 1 times 10 to the 9th nanometers. Okay? Remember, whoops, make sure that looks like an exponent. Another way of saying this is we're moving our 1 9 places over. So 1 meter equals nanometers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nanometers are incredibly small. We'll need this conversion a little bit later. Okay? So what is our wavelength? We have a frequency, and we know the speed of light. So we're probably ending up using the same equation here. Now we're looking for wavelength. We're looking for lambda. So we want speed of light divided by our frequency. Okay? So speed of light. Let's write down our equation first. Lambda equals c divided by f. So now we have, start with the first one on top, 2.998 times 10 to the 8th meters per every 1 second. Okay? And we want to divide that by our frequency. Our frequency is 6.01 times 10 to the 14th hertz. We'll draw a line here, new box, and this number is going onto the bottom. Okay? Now remember, hertz is the same thing as a number per every 1 second. Okay, so what we're going to do is we're going to flip that around. We're going to have 6.01 times 10 to the 14th. So this is our number, okay, per every 1 second. Okay? We can write that either way. All right? So when you have 1 per second or 1 second per unit. Okay? The reason we're going to flip that we want the number on the bottom because we're dividing it. And then also if we take a look here, seconds should cancel out. Seconds, we're left with meters. Okay? So let's plug our number in. Practice again. 2.998 exponent 8. Okay, that's our speed of light. We're going to divide that by 6.01 times 10 to the 14th. 6.01 exponent 14. And our number is 4.988 times 10 to the negative 7th. Okay, that's how we read that. Now in here we want to round to, I want 3 significant digits. So 4.98, this number changes it to a 9. So we have 4.99 times 10 to the negative 7th. And let's see what we're left with. We're left with meters. Right now our answer is in meters. Okay? We want to change that to nanometers. Okay? So, in order to do that, we're going to use this number here. 4.99 times 10 to the negative 7th meters. Draw our box. We want meters to cancel out. So here's where we use our unit. We know that 1 meter is the same as 1 times 10 to the 9th nanometers. Okay? So looking here, meters will cancel out. Both numbers are on top, so we multiply them out. By doing this, we should be left with nanometers. Okay? So 4.99 exponent negative 7. And we're going to times that by 1 exponent to the 9th. And now we have 499 nanometers. Okay? So just because I'm out of room here, I'll place my answer right here. 499 nanometers. meters. And that's what we measure wavelength in. So we're looking pretty good. Okay? So, is it in the visible range of the electron spectrum? See the table for question 5. 499 nanometers. Let's take a look. 499, which means, yes, we are within the wavelength of it. We are green. Okay, let me put that on here as well. Okay, let's do another one. Calculate the energy of a photon of radiation with a frequency of 8.5. Okay, so I'm looking for circle. Calculate the energy of a photon. Frequency is 8.5 times 10 to the 14th. Okay, so we have frequency and we're looking for energy. Okay, so looking at our equation up here, energy of a photon equals Planck's constant. And this is a number that we know. Okay, in fact, let's write that on here. Did we write that anywhere? 6.626 times 10 to the negative 34th joules times a second. Okay, that's Planck's constant, and we have frequency. Okay, so this equation looks like we're setting it up the same way. E equals H times F. So, set up our box. First number is Planck's constant, 6.626 times 10 to the negative 34th joule times a second. And we're just going to put that over 1. Okay? We're now going to multiply, so the next box over gets our frequency. And our frequency is 8.5 times 10 to the 14 hertz. Okay, another way of saying hertz is a number per every 1 second. Okay, so now numbers on top are multiplied, anything on the bottom is divided by. These are both 1, so we don't have to worry about it. Right now, if we cancel out, seconds cancels out with our seconds down here, we're left with joules, and that's what we measure energy in. So we know we probably set this equation up correctly. So let's plug it in. 6.626 exponent negative 34 times that number by 8.5 times, or exponent, 14. And we get 5.63 times 10 to the negative 19. Okay, 5.63. Our 2 says that this number stays the same. Okay, so we have our 3 sig figs, 5.63 times 10 to the negative 19th. Okay, and this is in, we're left with joules. So that's our unit that we're measuring in. All right, let's take a look at the back really quick. And I want you guys to work on 4, 5, and 6. Let's figure out what equation we're using first, though. So for number 4, calculate the energy of a photon of radiation with a wavelength of 6.4 times 10 to the negative 7th. We want the energy of a photon, and we have a wavelength. Okay. So we can't use this equation because we don't have frequency. We do have wavelength. Okay, energy of a photon equals hc. So it looks like this is our equation we're using. Right now we want to know energy, so it's h times c divided by lambda. So always write your equation first. E equals hc over lambda. Okay. So let's just get you guys started. First is h. This is Planck's constant, 6.626 times 10 to the negative 34 joules times a second. Next box over, we're going to multiply it by c, speed of light. 2.998 times 10 to the 8th meter per 1 second. Okay? And lastly, we're then going to divide by our wavelength. So wavelength is 6.4 times 10 to the negative 7 meters. Okay, let's see what cancels out here. Seconds cancels out with seconds. Meters cancels out with meters. We're left with joules. We're looking for energy. Energy we measure in joules. We know we've set this up correctly. To plug this into your calculator, take this number, multiply it by 2.9998 times 10 to the 8th, divide by our wavelength. Circle your answer. Make sure you have J behind it because we're measuring in joules. Go ahead, set up problems 5 and 6 also, and I'll help you guys out with this.